Hello, my name is Ashley. I'm a postdoc here at Radboud University in Nijmegen, the Netherlands. And today I'd like to talk to you briefly about galactic neutron star populations, how they're distributed on the Milky Way, and how this compares to fast radio bursts on their host galaxies. So all this work is described in a paper that we've recently submitted. You can find a QR code for it up there, and also you can search for Chrimes et al. 2021. So this work was inspired by the question of what are the progenitor systems of fast radio bursts. Now, the recent association of FRBs or FRB-like bursts from the galactic magnetar SGR 1935 might suggest that all FRBs come from this kind of source. But there are also lots of other theories that invoke magnetars, or neutron star systems, I should say, but not necessarily just magnetars. However, if SGR 1935 is representative of the wider FRB sample, then that means that the Milky Way is an FRB host, and that the distribution of magnetars on the Milky Way should then, in theory, match the distribution of FRBs on their host galaxies, in terms of how they are correlated with star formation and with stellar mass. So to test this, there's 3 steps we have to do. We have to create an artificial image of the Milky Way as viewed from outside, place galactic neutron star systems on this image, and then measure them, their positions, as if they were extragalactic transients on their host galaxies. So we did this. To create the Milky Way image, we simplified it into 3 components: arms, disk, bulge. Then we placed 4 galactic neutron star systems on this image, and then measured the offsets, the host normalized offsets, the enclosed fluxes, and the fraction of light. We have 4 different populations, 8 different types of measurement across 2 bands, B and I band, and this gives us 32 different comparisons to make to extragalactic transients. What are the uncertainties in this? Well, the main one really is the distance uncertainties to the neutron stars, although this is most significant for the magnetars, and also the galaxy model, including the spiral arm positions. But we minimize all of this by restricting the analysis to our side of the Milky Way, and we also do an F-light comparison of just the local disk, where all the distance uncertainties are smaller. So overall, as a percentage of Anderson-Darling tests between these distributions and various extragalactic transients, we find that FRBs best match the galactic neutron star systems compared to all the others. We can't differentiate for each transient which systems are the best match, but overall this is a promising method for future studies when FRB host populations are expanded. Thank you for your time. If you have any questions, please feel free to contact me. Thank you.